Who's ready to use some trig identities?
Mr. Hoffman, I think I ruined it. I think I messed something up. I think I saw the answer.
We're going to prove the answer.
I think it's... Can I guess?
No.
On page...
Sine of x plus h is sine of x cosine of h plus cosine of x sine of h, as you all remember from pre-calc last year.
Yeah.
Definitely. So this is the angle sum identity for sine, which allows us we're going to rewrite this. So that in this first part, we can factor out of here a sine of x. And then I'm going to split up my different limits. And we have some limits that we know. There's one that we don't, which I'll talk about. So this part becomes this. Plus, and then this part becomes this. And this limit I haven't talked about, but this limit as h approaches 0 of cosine of h minus 1 over h is 0. That's another identity like sine of x over x that sometimes you learn when you learn about these different types of limits. So this part turns out to be 0. So then we have cosine of x times the limit as h approaches 0 of sine of h over h, which is 1. So we get this is sine of x times this limit is 0 plus cosine of x times this limit turns out to be 1. And so the answer turns out to be cosine of x. And we can do something very, very similar for cosine using the sum identities and these limits, except the answer is going to be slightly different. And so the derivative of sine of x is cosine of x. And then the derivative of cosine of x is negative sine of x. Derivative of cosine is negative sine. So we'll do some examples using these derivatives. F of x is 1/3 sine of x, so f prime of x. If there's a constant out in front, we're going to leave it as a constant out in front. 1/3 derivative of sine of x is cosine of x. Next one. G of x is x minus cosine of x. So that means g prime of x is going to be derivative of x is just 1 minus derivative of cosine of x is negative sine of x. So that's going to equal 1 minus a negative sign is going to be 1 plus sine of x. So derivative of sine is cosine. Derivative of cosine is negative sine. Let's talk about a common application question with rates of change here that use derivatives. This is talking about if I know the position of an object, if I know different positions of those objects, and I want to figure out the velocity at which they are traveling, the velocity would be how that position is changing over a change in time. So it would be a change in distance over change in time. And so that becomes a derivative of that position. So we put time on the x-axis and position on the y-axis. Then the derivative of position would tell us the velocity. If I knew the velocity, if I knew the change in position over time, what would the derivative of that tell me? How much the velocity is changing over time. In other words, it might say that the velocity is increasing. So that might mean we're going faster. If the velocity were decreasing, that might mean we're going slower. So that is a measurement of acceleration. So the rate of change of velocity turns out to be acceleration. And so this touches on an idea that I want to go back to, which is that we can actually look at rates of change of rates of change. In other words, we can take a derivative of a derivative. So what that looks like here, I just realized that I didn't, there's a homework. I just realized that there was a set of problems I didn't do. So we can, this is at the bottom of the last page. We can actually take derivatives of derivatives. Let's look at what that looks like. So f prime of x is derivative of x cubed. Remember, the 3 hops down out in front, and then we have an x, one gets subtracted, so to the second power. Plus, derivative of 4x is just 4. And then derivative of 5 is 0. Derivative of any constant is going to be 0. Good with that so far? Okay. Now, I have this new function. I can take the derivative of it as well. And this would be called the second derivative. F double prime. Derivative of 3x squared is 6x. Derivative of 4 is 0. There's the third derivative. And then derivative of 6 is 0. And then I'm not going to write the derivatives after that because they're all 0. So go ahead and try the same thing with the next example. Take all the derivatives down until you get to 0. Sometimes in this notation you'll see, because if we have the 30th derivative, which we could hypothetically have, we don't want to write a whole bunch of primes across the screen here. And so sometimes you'll see a little number in parentheses like this. So this is the 5th derivative, so I'm going to put a little 5 there. Here's 0. Good to go on that? All right. Now let's look at velocity and acceleration. Velocity can be 0. If the velocity is 0, that means that we are not moving. If the velocity is positive, that means we're moving in a positive direction. So usually when we talk about that, that means we're going to be moving to the right. And then a velocity being negative tells me that we're moving in a negative direction. That's why usually we don't talk about velocity when we're talking about how fast something is traveling. When I ask how fast, we're usually talking about speed, which is just take the absolute value of velocity, make it positive. Right? So if there's a question about speed, then that's asking for the absolute value of velocity and for you not to worry about the sign. But velocity itself could be negative. That means that we are either that our velocity is either traveling leftwards or downwards or in some negative direction. But the main thing you need to know is that the derivative of position is going to be velocity. The derivative of velocity is going to be acceleration.
Say that again. The derivative of velocity is acceleration.
So the order goes position into velocity into acceleration. So if I take the derivative of position, I get velocity. If I take the derivative of velocity, I get acceleration. Usually we use S to stand for position. Part A is not a calculus question. That's an Algebra 2 question. The diver hits the water. No calculator, by the way. The diver hits the water when, what variable are we interested in? This is a question about, we're asking about time, right? The answer should be a time. That's a when. But the diver hits the water when we know about position. The position is going to be what? 0. This is not as difficult as it looks, because what I'm going to do is I'm going to take a negative 16 and factor it out. So I'm taking a negative out, that means it's going to be minus t minus 32 divided by 16 is 2. What are our answers?
3.
Set each part equal to 0 and solve. Negative 1 and 2. So we have 2 answers. Yeah, we're not going to hit the water before we go off the diving board. So 1 second before.
Yeah. He jumped up and was in the air for 3 seconds. Hypothetically, not possible. How high can dolphins go?
Seconds, maybe. So 2 seconds is when the diver hit the water. So now we can answer part B, which is the calculus question. What is the diver's velocity at impact? So we are interested in the velocity when t is 2. We just found when they hit the water, when impact was. So we are interested in v of 2, which velocity would be the derivative of position. So we're looking for s prime of 2. S prime of t is going to be, derivative of negative 16t squared is going to be negative 32t. Plus derivative of 16t is 16. Plus derivative of 32 is 0. So s prime at 2 is negative 48 velocities. No, we're looking at feet per second. feet per second, since our position is measured in feet and our time is measured in seconds. Right? Questions on that? That's the last page of the notes, right? Or like that's the last bit of that set of notes. Okay.
Well, we were saying yes.
I had a just so you know, instead of doling out little bits of homework assignments, because I kept forgetting to give the next homework assignment, and that's not good because then you get less time. I decided to just post them all at once on Canvas, if you didn't see that yesterday. Right now, you should be capable of doing the first 4 assignments that I have given. So you should be able to do the first 4 assignments. Remember, the first one is the only one where you need to do the long limit definition stuff for the derivative. The rest, you just want to use shortcut. Next page in the notes. Point slope form. No, that's not point slope form. Anyone know what it is? What else? So if we have a point and a slope, so here's our point. It goes in there. This is for equations of tangent lines. There are going to be problems where you're going to be asked to write the equation of the tangent line. And this is where your slope goes. So to get the point, plug into f of x at whatever point we're looking at. Plug in the number for x, get out the value for y. But that doesn't tell us the slope. If only we had some function that we've been looking at that would tell us the slope. Oh, that's right. The derivative. If I put in the derivative, I get out the slope. So on these problems, we're going to figure out the point, figure out the slope, write our equation. So let's look at an example of that. We got this written down? Okay. I'm going to try and get through 2 of these examples before we go. So first off, we're going to find f of negative 2. F of negative 2, plug in negative 2. 9 minus 12 is negative 3. So negative 2, negative 3 is our point. F prime of x is derivative of x squared. 2x plus derivative of 6x is 6. So we want to take f prime at that point. Plug in 2. 2 times, plug in negative 2. Plus 6. It's number 3. You can tell by how it says number 3 up here. Number 2 had bigger numbers, and so I didn't want to deal with it at the moment when I'm short on time here. Negative 4 plus 6 is 2. That's the slope. When I plug in negative 2, my slope turns out to be 2. Y minus the y coordinate equals the slope times x minus the x coordinate. And this is going to end up being our final answer here. Y minus our y coordinate was negative 3 equals our slope turned out to be 2. X minus our x coordinate turned out to be negative 2. So our final answer here is y plus 3 equals our slope of 2 times x plus 2. Okay. One more. This is number 5. F of pi over 3 is cosine of pi over 3, which, as you all know,
Let me think. No, it's square root 3 over 2. Right? And it's a 1 I read it. Let me guess. Square root 3 over 2.
we're dis-
Down. It's 1 half. There's 1 half. Square root 3 over 2. You almost wrote it down. Yeah, it's definitely 1 half. You're right. Wait, no, it's not. It's square root 3 over 2. Oh, did I?
Jason over hypotenuse is 1/2.
No, I did not. No, I did not get that.
Derivative of cosine, negative sine. F prime of pi over 3. Negative sine of pi over 3. Which is negative. Now the sine of pi over 3, square root of 3 over 2. So we're going to have y minus our y coordinate is 1/2 equals the slope, negative root 3 over 2, times x minus your x coordinate, which is pi over 3. So the slope is f prime at the value, to get the point, we're going to plug into the original function. So on Monday you're going to finish up and do the rest of these, but we're going to continue with notes tomorrow and what's the day after that? It's Friday. Thank you.
Tomorrow and after tomorrow.
It's been a tiring week. I'll get